For today's functions are our next lesson. The function are some methods slash procedures. So when you have some batch of code marked together, built in together in some body that we call the function. Together, the code gives us some solution or gives us some value or some printing, etc. The functions are mainly used when you're having some repeating of a given blocks in the code, and you say, okay, this will be some function, and we will call it and use it when we need it if it's frequently used in the code. Firstly, we're going to take a look at the built-in functions in Python. Python has, as I said, many different functions that are applied, and you don't need to import any mathematical package like in Java, for example. In Python, mainly it's used because its ability of different functions that are coming with the imported packages, and it can be either for mathematician rules, or it can be some data science analysis and models that are today very trendy. So Python, it's, I will say, trend language based on its functions that it gives to us. And we don't need to search, build new functions. For example, if I need some, let's say, a non-value pre-processing, and we need to handle the missing values, then okay, we have some already built functions in Python, and I will use them. And we don't need to build new ones. Now, we will talk about the base rules that Python has, and in some other course, you will take a look of, as I mentioned, data preprocessing that Python gives us as a feature. For the numbers, we can start with some mathematical rules, like round of the number. We're having some 10 divided by 3. That's a value of 3.333, but it's rounding on integer value. Like if I write some decimal value, it will round it on 1. If I write some decimal value, that's 1.6. As you can see, if the decimal part is bigger or equal to 5, then the value of integer is getting the upper value. If I take, for example, absolute value of -1 is 1, or positive is a positive number, of negative is positive. You know, it's mathematical rule. If I take maximum from 10 to 5, it gives us 10. If I add here some expressions like 10 multiplied by 8, it will give 80. If I add here string, as you can see, instances for string and integer are not supported, because what's the max value in the back in the source code? It's taking, is this number bigger than, is A bigger than B, is B bigger than C, etc., and it gives us at the end the maximum value. If you're adding a string and integer can't be compared together. Maybe if we add integer of 5 as a string, then it will give us a value. The same with the minimum value, 10, 3, and plus 2. You can add minimum and here a maximum, for example, 10 and 5, or another minimum of 1 and 2, and you can see that 1 now will be the minimum. This maximum gives us 10 as the value, minimum gives us 1, and then it's calculated 10, 3, 12, 10, 1 minimum of that sequence. For the operations, for example, 100 is bigger than 99 plus 1, this will give us false because firstly it's calculated this and then plus 1. Okay, if I add here that this is expression, this will give us, if I add equally, then it will give us true because this is not a bigger number. Okay, maybe let's see. As you can see, we missed the equal sign. If I make something like this here smaller, let's take a look, smaller, it's true. But if I add this expression right here, plus 1, it will give us 1. Why? Because this is false. The false part gives us 0, plus 1 gives us 1. Now, if we want some advanced mathematical operations, we are importing the math and importing the operator packages or libraries. In Python, all libraries are called packages because they are like one package of um, all functionalities, like a given script with many functions in some field. For example, math and operator are for mathematical based approach. For example, a square root of 9, it will give us value just to import now a value of 3. If I take 10 minus 1, it's 9, and then add 0.5 on degree, it will give us value again 3 because this here is on some degree its power. With math, we are having log, its logarithm function from 8, and here we are with control space. You can see the functions that we have. Let's take a look. Here are all the functions. If we go to log and if we make control space, we can see that log has base and x value. I'm gonna add for log x value 8, for base 2. If I don't write the base 2, by default the value is 10, the base value. And by mathematician rule, if I divide two logarithms with same base 10, it will give us a number of 8 with base 2. This is just a mathematical rule applied. We talked that we had bool as a value of true and false in Python. Now, how can we get from numbers and strings a bool value? The cast is bool, and here writing the value. For example, for 100, it's true. For minus 10, the value is true. Only for 0, the Boolean value will give you false. This is for numbers. When we're talking about strings, we are having bool from AAA. It's a true. From just one character is true, but of empty string, it's false. Now, for strings, we're having some of the mathematical functions applied here. For example, a maximum of AA, BB, it's giving BB as a value. I'm gonna implement here 3Bs, so this is bigger. We will say, okay, the length of B is bigger than A, but what if I add more A's than this? as you can see, the maximum value here works on ASCII codes. The ASCII code of B is bigger than the ASCII code of A. So it's looking the alphabetical order. A is previous letter, B second one, so B has bigger ASCII code. Again, with the minimum, this will gives us A. Okay, it compares A with B. If B is bigger number, then it returns A. If this starts with A and B as a second, again, it will gives us A. It goes one by one equal, then second letter B, A, compare it. B is bigger B has bigger ASCII code, bigger integer number, than A is the minimum value. If I take the len, it's the length. This function gives us the length of a given string. For example, of Python, the length is 6. If we want to lower or upper the values, we're having Python, and then upper value is just the upper function, and all the letters are caption. If we want Python to be to lower, it's lower, and all the values, all the letters are small. If we have, for example, Python with B, we're having replace function that will replace B with B. What is here different? The replace is case sensitive. So if you say B with small, it's like small letter, it will not replace it. But if I make lower previously and then replace it, it will find and replace the value. Now, if we compare two strings, AA smaller than BB, this will return true. But if we say B is bigger than C, this will return false. Why? Because B is having smaller ASCII code than C, and if I add smaller at the side of B, then it will return us true. When we are talking about types, I think that we passed in the previous video about types, but if we look at the types of the functions, type of minimum, it's a function, built-in, or method. Now, if we take type of string, it's string. If we take from more than one character, string. If we take type from a value, for example, a value, its type, it will gives us the type of the given number, for example, float. What is something new that's in Python, that we're having none as a type. This none in Java and other object-oriented language is called none, and gives us exception. In here, it gives us none type, and you can say if a given value is having a none value, so we can say A equals none. Here none. A equals none, and this will gives us true as the value. It's like in Python, none, it's a given type of value. With this, we're closing with the built-in functions in Python.